In the last lesson of this module, we'll discuss probes. When working in a microservices environment, you'll have service dependencies. If a service isn't ready, another service might generate an error. Also, some containers might appear to be operational because they are consuming compute resources, but in fact, they aren't able to service client requests. In both of these cases, the other microservices would generate errors that we can prevent by checking the status of a pod. And if it's found to be non-responsive, redeploying it. In this example, the shopping process is broken down into various microservices such as orders, shopping cart, and credit card processing. It's vital that the orders are saved appropriately in the shopping cart. If the orders aren't saved correctly in the shopping cart, the credit card won't be processed correctly. This might eventually lead to a lost conversion and ultimately lost revenue. Overall, it's essential to have a functional shopping cart microservice. So how do you know whether the shopping cart is functioning properly? It's best to apply additional health checks such as liveness and readiness probes. With a liveness probe, Kubernetes checks to see whether the container is running. If the liveness probe fails, and if the restart policy is set to always or on failure, Qwiklabs will restart the container. With a readiness probe, Kubernetes checks whether the container is ready to accept requests. If a readiness probe fails, the pod's IP address is removed from all service endpoints by the endpoint controller. These probes can be defined using three types of handlers: command, HTTP, and TCP, to allow you to perform different types of diagnostic probe tests. How do you decide whether you need to use a liveness or readiness probe? Consider some common scenarios. If your container can fail by itself and the restart policy is set to always or on failure, you don't need a liveness probe or a readiness probe. Qwiklabs will simply act based on the defined restart policy and restart the container. However, if an application within a container is stuck in a broken state and requires a restart, you can set up a liveness probe to detect the broken state and restart the container. The third case where a probe can help is where your container might be running, but your application isn't yet ready to serve the traffic. By default, Kubernetes would send traffic to the container because it's running. Even if you've set up a liveness probe, the liveness probe will simply fail and restart the container. This just ends up in a continuous loop with the application never getting to a state where it's ready to receive traffic. In this case, you can add a readiness probe to make sure your application is ready and running before the traffic is sent. Note that if you don't specify any of these probes, by default, Kubernetes assumes that the pod executed successfully. With the command probe handler, Qwiklabs runs a command inside the container. If the command succeeds, in other words, if its exit code is 0, the container is considered healthy. Otherwise, Qwiklabs will kill the container. The second type of probe handler, HTTP, uses an HTTP GET request. If the request returns with a code range from 200 to 400, Qwiklabs considers the container healthy. Anything outside that range will kill the container. You can easily set up a lightweight HTTP server on the container to use this probe. The third probe handler type is TCP. Here, Qwiklabs attempts to make a TCP connection. If the connection is established, the container is considered healthy. All these methods can be used in a readiness probe in exactly the same way. You can refine these probes. The initial delay seconds field sets the number of seconds to wait before liveness or readiness probes can be initiated. it's important to ensure that the probe isn't initiated before the application is ready. Otherwise, the containers will be thrashed in a continuous loop. This value should be updated if your application boot time changes. The period seconds field defines the interval between probe tests. The timeout seconds field defines the probe timeout, and success and failure threshold fields can also be set.